Okay, so in this video I'm going to prove that the square root of 3 is an irrational number. And I'm going to do that using a type of proof called a proof by contradiction. So we're going to use a proof by contradiction. So the way we're going to do this is we have to prove that the square root of 3 is an irrational number. So what I'm going to do is assume that it is a rational number and then show that the fact that I'm assuming it's a rational number produces a contradiction. So let's start off. We're going to say that the square root of 3 is a rational number. So we're going to say that the square root of 3 can be expressed, the square root of 3 can be expressed as a fraction, a over b. So a and b then, a and b have to be integers, elements of z. So in other words, a and b are positive and negative whole numbers, and b then of course cannot be equal to 0. You can't divide by 0. So that's the definition of a rational number. It's a number that can be expressed as a fraction or in the form a over b, where a and b are integers, positive or negative whole numbers, and the bottom number or the denominator cannot be 0. So we want to prove that the square root of 3 is irrational, that this cannot happen. So what we're going to do is assume that it can happen and then go through a series of steps and show that if we do assume that it can be expressed as a fraction, then it produces some kind of a contradiction. Now, what we're going to assume here as well is that the fraction a over b is in its simplest form. In other words, for example, if you take a fraction like, say, 2 over 3, that fraction is in its simplest form. You can say that it's equal to 4 over 6, just double the top and the bottom, you get 4 over 6. This here is not in its simplest form. The simplest form of 4 over 6 would be 2 over 3. You can't simplify it any further. So we're saying that root 3 in its simplest form is a over b. In other words, the highest common factor, the highest number that will divide into a and b is 1. So the highest number that will, common number that will divide into a and b will be 1. In this case, for example, in this case here, 2 over 3, the highest number that will divide into 2 and 3 is 1. The highest number that will divide into 4 and 6, the same fraction but not in its simplest form, is not 1. It's actually 2. We can divide the top by 2 and the bottom by 2. So what we're going to actually show in this particular proof is that we're assuming here that the highest common factor for a and b is 1, but what we're actually going to show is that in fact a is divisible by 3 and b is divisible by 3. So there is a higher number, bigger than 1, that will divide into a and b. So let's start doing that then. Okay, let's just move this up a little bit, and what I'm going to do is square both sides first of all here. So I'm going to take root 3 and square it. That'll give me 3. Root 3 times root 3 is just 3. Square the right hand side, I get a squared over b squared. Now I'm just going to cross multiply here if you like, so a fraction equal to a fraction. 3 times b squared is equal to 1 times a squared, so a squared is going to give me 3 times b squared. Now I'm just going to mark this particular equation. We're going to use this again later on. So let's just look at this, what we've got here. We've got a squared. Remember, a and b are both integers, and remember that if you have an integer and you multiply it by an integer, you get an integer. That's one of the properties of integers. So we have an integer a, we multiply it by another integer a, same integer in fact, so this a squared is an integer. B times b, or b squared, here is also an integer, and we're multiplying it by 3, which is also an integer. So the right hand side is equal to an integer. In other words, a squared here is some multiple of 3. A squared is some multiple of 3. In other words, we can multiply some number by 3 and we will get a squared. That means that a squared is divisible by 3. 3 will divide into a squared. 3 will divide into a squared. Now, we know as well that if a number divides into a number squared, then the number divides into the square root of the number. In other words, if you have 3 dividing into a squared, 3 will also divide into a. That's what I'm trying to say here, really. So 3 will also divide into a. Now, we know now that a is divisible by 3. So that's the first part of the proof. We assumed here, remember, that we're saying that that the highest common factor of a and b is 1. We've now shown that a is divisible by 3. We're now going to go on and show that b is also divisible by 3. That's going to contradict this here. That's our proof by contradiction. So we've shown here that 3 divides a. So let's move on to the next step then. So now we're going to show that 3 also divides into b. Now, we're going to start this by just saying here that a is divisible by 3. So that means that a is going to be equal to 3 times some number. If we divide a by 3, we're going to get some number. We're going to call it k here in this case. And k is going to be another integer. So we know that 3 divides into a, so a divided by 3 will give us some number, and we'll call it k. In other words, a is equal to 3 times k. A is some multiple of 3. Now, so if a is equal to 3 times some number k, what I'm going to do is take this particular equation here again, the one that I've marked up here, and instead of the a here, I'm going to put in 3k because they're equal. So 3k squared, we've got a squared, so now I'm writing, instead of a, I'm writing 3k squared, and that's going to be equal to 3b squared. Okay, so if I just multiply this out, I get 9k squared is equal to 3b squared. 3 squared and k squared here. Here only the b is squared. The 3 is not squared here. Okay, so let's just divide across by 3. 9 divided by 3 is 3, so I get 3k squared. And divide this side by 3, I just get b squared. The 3 will divide by 3 to give me 1, so that the 1 is here if you like. Now, in this particular case, we see that b squared is some multiple of 3. Remember, b squared is an integer, k squared is an integer. So b squared is some multiple of 3. We can multiply some number by 3 to give us b squared. In this case, we're multiplying k squared by 3 to give us b squared. Now again, if 3 divides b squared, so we know that b squared is divisible by 3. It'll give us a whole number, k squared here. So in other words, k squared is equal to b squared over 3, if you like. If we divide b squared by 3, we'll get some integer here. We'll get a whole number. So we know that b squared is divisible by 3. 3 will divide into b squared. That means that 3 will also divide into b. Okay, so now we've shown that not only does a divide by 3 to give us a whole number, b is also divisible by 3 to give us a whole number. So now look what we've done. We started off with the assumption that the square root of 3 is equal to a over b, where the highest common factor of a and b is 1. But now we've shown that that's actually not the case. The highest not the highest common factor, but there is a higher number than 1, i.e. 3, that will divide into a and also divide into b. So that contradicts our initial assumption. So that's our proof by contradiction, that the square root of 3 is in fact irrational.